I will, in the beginning, will quickly tell about my background and then describe all components sequentially. I am a data scientist in insurtech company, Sprout AI. We help a big insurance company to recognize documents and do some NLP reasoning. For particular, I focus on policy document question answering. It based on information retrieval and LLM models as well. First component in my solution was obviously a knowledge database. I checked a few Wikipedia database dumps. I also check, I'm sure everyone tested a wiki parsers. It seems like this script's outdated and it's really time-consuming and painful to parse properly Wikipedia. I gave up and fortunately found a Wikipedia dump on Hugging Face database. It dates to summer of 23. Seems like quite fresh dump, and each document a whole page from Wikipedia. I split these pages into chunks, in average 1,000 characters, and fit it into a sparse database, or in particular Lucene. And I also found a nice notebook which show it possible to run in kernel mode a whole Lucene retrieval. In the end, my database dataset in average 18 gigabytes, and check 4,000 question takes, I think it takes 4 hours or so. Next step, when I retrieve a few documents from this sparse database, I rerun them with custom trained model and explain this model. I will explain how I build a dataset for this model. Typically, a multi-choice dataset consists of questions, few answers, some options wrong, and additionally we have a context for each of these options. To train a custom Jupyter model, I choose a question, correct answer, and retrieved a few related contexts for this correct answer. Then I rerun this context with a teacher model, with another multi-choice model, and I build a pseudo-label or a ground truth label for a rerun model. In this particular example, a second context, number 1 is higher score, and I use this particular context as correct answer to train rerun model. And the rerun model is typical multi-choice model, but instead of choose different options, I choose different context. For multiple choice model, I use 2 types of models. Jupyter, most of my experiments I done with Jupyter, but I also fine-tune a few LLMs models, and from my experiments, Mistral show a better results. You can see quickly LoRa config I choose almost all projections. And on this screen, you can also see a datasets what I used. Try to use all publicly available datasets. I didn't generate any questions. And you can notice some of these datasets are non-commercial. But to be honest, it seems like adding a mod data, it's not helpful. And the same results could be achieved with much small data sets. I also spent some time for alternative solution to multi-choice. Instead of predicting a score for single options, I predict a score for different words for particular questions. Hopefully this example gives you understanding. I noticed at least Jupyter show a really bad results on this type of questions when we have a really long options and they different only in few words. For this particular questions, I fine-tune a mask model, and it show at least on my data, it show a better results. Unfortunately, on private data set, it doesn't show any advantages. I also seems like waste my time on cross-reference options. Seems like in the end, it doesn't matter. A cross-reference from my definition, it's options when they refer each other, like none of the above, all of the above. And technically, we can triple a data for none of the above options when we, for each, we can replace all correct answer with none of the above options, or we can add additional none of the above options. Again, it seems like not, it was not useful in the end. And finally, I built a second stage model, XGB ranker, which based on 7 features. Most important, it's log its output from a Jupyter model and Mistral model. Each of this feature extracted for each 5 options. And I fine-tuned this model in kernel. If you check my notebook, you could notice I also did a pseudo labels. It means I took a test data and added pseudo labels and trained on this, but it doesn't give much advantages. In the end, my solutions seemed like main components from my solutions. It was a whole Wikipedia index, real ranking model. You could see quite reasonable diff when I re-rank 8 top documents from a Lucent database, and also a huge jump when I added LLM model. Yeah, that's main components.